Hello, and in this video we're going to look at the rule of 70. This is also found in section 5.3. It's a rule to estimate the doubling time. So for quantities that grow exponentially at p% per time period, that means we can use any time period we want here for this. It doesn't matter what time period it is. We could be doing years or months or hours here. So if we have a p% per time period, the rule of 70 gives a quick way to estimate the time it takes to double in size. So the doubling time is going to be 70 divided by p, approximately. Okay, so that's why it's called a rule of 70. It's 70 divided by p. So for example, if you're growing, the city is growing at a rate of 5% per year, the doubling size will be 70 divided by 5, or 14 years. Now p is in a percent here, so you don't have to change the decimal unless it gives you a decimal, then you have to change it to a percent. So that's our estimate, and we will be checking that with our actual values later on. So another example here would be like if we had bacteria growing at a rate of grows at 7% every day. So if we had that, then our doubling time would be 70 divided by 7, or 10 days. So it would take 10 days to double. So this is in days because our 7% is in a day. This was in years because it was 5% per year. So it's used whatever time period they have there for the percent. That's what we're going to be using. Here's some examples down here. This is on your worksheet for the rule of 70. So if you want to try these out before we want to do this, you can do that beforehand. So it says we have 4.2% growth percent in employers in 2012. So here's some recent statements. Growth rates, rewrite the statement in terms of doubling time. So if we want to do that, what we would do is take 70 here divided by 4.2. Let's do that. 70 divided by 4.2, we get 16 2/3. So that means that we would write this as it grows, healthcare prices double, healthcare costs double every 16.7 years in this case. All right, because we're talking about years here, 2012, so we're going to be that many years. Okay, so the next one, we're going to do 70 divided by 11%, and that would be 6.3. So property crimes double every 6.4 years starting in 2011. This is doubling starting in 2012 for that one. Alright, now on this one we're going to take 70, I should know what this one is right away, 70 divided by 0.7, we should get, oops, too many, we should get to 100. So we're going to say it doubles every 100 years. So starting in 2012, Oregon's population doubles every 100 years starting in 2012. All right. Okay, so in the last problem here, it says we're going to start with 5,000 people, and we want to get to 160,000. All right, use the rule of 70 to estimate how long that's going to take. Well, we know it can double, so let's do that. We can find our doubling rate by taking 70 divided by 6.2. We get 11.29, 11.29 years to double. All right, and then we're going to take this 5,000 and we're just going to take, okay, 5,000 is for our starting amount, so we're going to get to 10,000 in 11.29 years. We'll double again. So it doubles, then it doubles again, and another 11.29, so that's going to be 22.58 years to double again, so that's 20,000. Then we double again, we get 40,000. And then we double again to get 80,000, and then we double again to get 160,000. So it's going to take 1, 2, 3, 4, 5 doubling times. 5 doubling times. All right, so all we do is take 11. We already have that in there, so I'm just going to multiply that by times by 5, and that should give my answer. So we're going to say 56.45 years before it reaches 160,000 by using this estimation rule. All right, so that's a rule of 70. It's a quick way to figure out how it's doubling, how long it takes to double something. All right, and we can use that as long as we have something that doubles nicely here and gets us up to the same amount that we need.